Hi, thanks for coming. So today I'd like us to consider three important topics for conservation ecology, and those are biodiversity, invertebrates, and conservation. So first of all, ecosystem processes are compromised by biodiversity declines, and those processes are the net effect of ecosystem functions, which are the things that organisms do. So any loss of functional diversity will have an influence on ecosystem processes. In some cases, species can decline to functional extinction, and that can happen before species are considered to be rare. A good example of this is with Pacific fruit bats, where at normal density the males fight over fruit trees, and that results in normal food dispersal. However, because of hunting and habitat clearance, males have dropped to a lower density, and that's removed the need for them to fight with each other, and that results in poor seed dispersal and no long-distance recruitment of new trees. And by the time that effects of this functional extinction become noticeable, it's often too late to make any interventions. In Australia, we've achieved a particularly special level of biodiversity declines. We're now second in the world for overall biodiversity declines in the industrial age. So in Australia, nearly 3/4 of our land mass is classified as either arid or semi-arid habitat, and nearly 1/3 of all native mammal species from those drier habitats are now extinct, and the majority of the remaining species are either threatened or functionally extinct. So that leaves 6 species that are okay. So special features of the remaining species and the ones that were particularly hammered by the declines were they were critical weight range species. They also had a few which occupied ecosystem engineering functions as digging marsupials, and they were also tended to be omnivorous or insectivorous species, and they were also active, obviously hosts for parasites and other fauna, such as dung communities. Luckily, it's possible in some cases to return those species to fenced habitats where predators have been removed, and these reintroductions have let me ask 2 questions about the biology of those systems. First of these is what happens to invertebrate functions when species are reintroduced, and the second is how do we measure appropriate baselines of invertebrate community composition where missing species can be reintroduced. So going through the methods briefly, I used manipulative and mentative experiments to measure the responses of subterranean termites in dung fauna to reintroduce mammals' presence. These were conducted in 3 sanctuaries where the native mammals were reintroduced, and 1 location where the focal species was a remnant population in the Tanami. The main contrast that I was using was inside versus outside fences, so essentially the presence versus absence of those reintroduced mammals. And for the dung fauna surveys, I used kangaroo dung as a baseline for a species that has never been considered threatened. So that would have a good comparison of intact versus impacted community. Throughout my sites, there was an important overarching variable of aridity, which has an influence on productivity and so therefore resource availability for termites, for example. So for the termite experiments, the background notes for that, as I said, reintroduced mammal assemblages at the sanctuaries included insectivorous and omnivorous species. Some of those animals were engineers digging a lot of holes and burrows. There were also, as insectivores, termites happen to be delicious, eaten by a lot of things, but they also, on the other hand, like to have a quiet life. So I thought termite functions might change when native mammal assemblages were reintroduced to those sanctuaries. So to do that, I looked at their biomass and abundance using trench surveys. I also looked at the amount of resources they would eat when I buried them at different depths, and I also looked at how many termites would run away from a resource if I attacked it, pretending to be a bilby. So outside the fences, where the mammals are still regionally extinct, we found a net abundance of 234,000 termites per hectare, which equates to a biomass of about 30,000 grams of termites per hectare, which is about 30 kilograms. For resource consumption, quite a lot of the resources got eaten. Termites were eating up to 3/4 of the resources we gave them, but only 1/4 of the termites would run away when we attacked resources for our experiments. The insides of the fences was a different story altogether. So when mammals were present, termite abundance dropped to less than 60,000 termites per hectare, with an equivalent biomass of 40,000 grams per hectare. Resource consumption also decreased to less than 15% of all resources being eaten, and the abandonment of those resources was way up, so 80% of the termites were remaining after 24 hours since we attacked those resources. So there's a strong effect of mammal presence on termites staying with resources and eating them. Across all sanctuaries, we also found an important influence of the aridity gradient, which was smallest at the most arid sanctuary and greatest at the least arid sanctuary. So we think that we witnessed a trade-off between resource value and predation threat, where specifically rare resources in the most arid habitat may be more important than predation threats. So the risk of starvation is high if you abandon food that's rare, whereas plentiful resources in the least arid habitats are less important than predation threats. So you're more likely to find some resources in a resource-rich environment. So it's okay to run away when you get attacked, but if your resources are rare, it's probably better to stick with what you've got instead of risking probably getting eaten and starving to death than the other way around. So with the dung fauna surveys, invertebrates can use animal dung as a resource for feeding and breeding. And the greater bilby is one of the animals reintroduced to all of the sanctuaries, but they have also declined from more than 70% of the historic range, and they may be functionally extinct, but they would have also acted as a host for dung fauna communities in some respects. So dung fauna communities must respond to host declines in one of two ways, and those are to find alternate resources, or they can go into decline with their hosts. So I expected dung fauna communities to change when greater bilbies are reintroduced with the addition of those resources back into those systems at the sanctuaries. So to have a look at this question, I checked out visitor activity and function to two different types of bait. So I compared bilbies against kangaroos, as I said, using the kangaroos as a baseline for a community with a non-declining host. All in all, we encountered 3,884 visitors representing 26 families and 68 morphous species, but there was no significant effect of bilby reintroduction on diversity or activity of the animals that we found. What I saw was a broadly opportunistic community comprised mostly of ants or flies, and the biggest challenge in this experiment was finding a reintroduced species with a remnant, and no specialists. So essentially the bilby dung communities were the same as those found on kangaroo dung. So the implications of the mammal declines for invertebrate function and diversity are quite context dependent. For the termites, they were responding to both physical engineering and trophic inputs, even though we didn't study that. It was quite likely that they were also getting eaten by the mammals. So these interactions led to changes in termite communities and their behavior, and it also had an association with a reduced function of the termites as decomposing species. Overall, aridity was very important, and it had a moderating effect on interactions, which changed the outcome of those interactions depending on where the animals were. For dung fauna, they were not influenced by host extinction. We found a broadly opportunistic community that was capable of using any of the resources that were available to them, and the biggest challenge was finding reintroduced species with a remnant population to use as a baseline for dung fauna community composition. So the nature of threatened species themselves is that they are few left in the wild, so functional extinction is quite likely in those cases. And so that would imply we have poor baselines to adequately understand the trajectory of functional recovery caused by returning threatened species to their historic habitats. So one of the ways we tried to get around that was to use kangaroo dung as a baseline for a fauna community with a stable host. But it was still difficult to give an indication of community composition in historic terms. Because, for example, what if we are left with species that are robust to it? What if all that we have left now is species that are robust to extinction and can just use anything as a result of widespread mammal declines? And we've lost like the really specialized kind of ones. So the take-home messages from the thesis that I'd like you to have are that invertebrate function and biodiversity in site enclosures should have considered management practices. Obviously, one thing doesn't fit everybody. So one of the important things that we found is that aridity is very relevant. Measurements taken in some places might not translate to other locations, so we need to make sure that we're when we use variables such as climate, that we are using them consistently across different sanctuaries. So don't use a moderate response in an extreme environment, for example. The other thing that we found was that baselines are still very important, and it's easy to forget about baselines because it's basically what we see is what we think is normal, and that may not be true all the time. So suggested improvement to help us find better baselines for comparison and assessing progress. We could create estimated baselines of dung fauna community composition using common species across a variety of habitat types and taxonomic relatednesses. And then we could create an average community composition of those intact fauna communities to compare against reintroduction communities. And that might help us to better detect the impact of host declines and regional extinctions, because we will know what to expect in terms of the functional composition of intact communities. And that will allow us to better assess the progress of restoration projects that we're using throughout Australia. Thanks. That's the end.